Okay, now we're going to have a look at how to write formula, ionic formula. So here we've got sodium chloride. First thing you need to do is remember or look up the charges of the ions. So sodium in its ionic form is Na+ as an ion. Chloride is Cl-. So it's very important that you get obviously the right symbols, but very important you get the right charge. Any compound, any ionic compound is overall neutral. It's not positive, it's not negative. So we want to know what ratio of sodium ions we need to chloride ions to make it neutral. Well, 1 plus cancels out 1 minus, so this one is simply, as I'm sure you already know, NaCl. Okay? Right. Same rule here. So it's very important that we know that magnesium is magnesium 2+, because it's in group 2, it loses 2 electrons. If you get that wrong, you get the formula wrong. Fluoride is the ion formed when fluorine gains an electron, just 1 electron, so it's F-. So again, the compound has to be neutral. So we want to know the ratio that we need to have of magnesiums to fluorides. So if you look, if this is 2+, we need 2 lots of the 2-. Okay? We need basically 2 of those, don't we? So the way we write the formula then is Mg F2, like that, to show that there's 2 fluoride ions for every magnesium ion. So as you notice now, there's, just like with one before the same chloride, there's no positive or negative on this compound here. Okay, the charges have been cancelled out. Let's have a look at a bit more of a juicy one here. So oxide is 2-, potassium 1+. We want to cancel out the charges. We want to have the same number of positive charges as we do negative charges. So we're going to need more positive charge, aren't we? Okay? So what do we do then? We need 2 potassiums for every 1 oxide, K2O. Alright, now we're getting to the serious stuff. Aluminium hydroxide. This one's slightly harder, slightly different, because this is a polyatomic ion. Okay? So, because it's polyatomic, we're going to have to use brackets here in a minute. Let's have a look. So, 3 plus 1 minus. We need 3 times the amount of these. We get 3 times the amount of OH minus for every aluminium. So if we went like we did before, Al, OH 3. Now the problem with leaving it like that is, as that reads, we've got 1 aluminium, 1 oxygen, 3 hydrogens. We want 3 hydroxides. So to show we've got 3 hydroxides, not just 3 hydrogens, we put brackets around like that. Okay? Next one. So here we've got 2 polyatomic ions. Okay? Right. Same thing though, we must get the formulas right. The carbonate is always CO3, ammonium is always NH4. Okay? Those bits aren't going to change when we write down the overall compound. So NH4 plus, CO3 2-, we need more plus charge. We need twice as much plus charge to cancel out the 2- in the ratio of this ionic compound. So it's polyatomic. So it's all of our NH4. I'm not changing the 4. Okay? It's still 4 hydrogens for every 1 nitrogen and ammonium. Need 2 of them though for every 1 CO3. So then we would have the total of 2+ cancelling out 2-. It has to be neutral. Okay, another one I've just thought of. It can get a bit trickier. What if we had, let's say, iron free oxide? Why is this one trickier, Stuart, I hear you say? Let's have a look. Iron free. So what does that tell us? It tells us the charge of the ion. It's Fe 3+. Oxide, O2-. Right, Now, why is this one a bit trickier? It's not straight away obvious how to balance out these charges. So a good trick to do is to basically swap the numbers round. So Fe we need 2 of, oxide we need 3 of. If you think why does that work? Because if you have 2 times that will come to 6 plus, and if you have 3 times that will come to 6 minus, and so overall that's neutral. So it's Fe 2O3. Okay? And if you can do that, you're ready for whatever they can throw at you.